Good morning to everyone. Today we'll look at 10th standard chemistry. See, already in the last class we saw about the ores and minerals, their uses, their properties, and about the extraction and the metallurgy of the different ores involved in the metallurgical process. Now we'll see the important metal, that is aluminium. You know that aluminium finds lot of application in our day-to-day life. We are using aluminium vessels in our kitchen, as well as in all the industries they are using this aluminium parts. So aluminium finds wide importance in our day-to-day life. So today we'll see about this aluminium. So this aluminium symbol, you know, Al. Aluminium symbol is Al. It is the most abundant metal and it is a reactive metal. So it occurs in combined state. Occurs in combined state. And then here the chief ores of aluminium. What are the different ores of aluminium? They are all bauxite, then cryolite, and then corundum. Bauxite and then cryolite and then corundum. Bauxite formula Al2O3 into 2H2O, and cryolite Na3AlF6, and corundum Al2O3. See, this can be asked in short answer. This can be asked in short answer, but if you remember the name as well as the formula, it's okay. But if you don't remember the formula, you at least remember the names of the different ores, that is bauxite, cryolite and corundum. What is the chief ore of aluminium? The chief ore of aluminium is bauxite. Chief ore of aluminium is bauxite. So here the chief ore of aluminium is what? Bauxite. What is the formula? Al2O3 into 2H2O. And here we are going to see the extraction of this aluminium from the ore. So here in the extraction of aluminium, it involves two steps. That is the conversion of bauxite into alumina. So the first step is conversion of bauxite into alumina by Bayes process. Conversion of bauxite into alumina by Bayes process. So this is very important. So this is a naming reaction, conversion of bauxite into alumina by Bayes process. Here the bauxite ore is taken. The bauxite ore is crushed and then grinded, and then to that I am adding concentrated caustic soda solution. What is this caustic soda? Caustic soda is nothing but sodium hydroxide, and caustic potash is nothing but potassium hydroxide. So I am going to take this caustic soda solution, that is sodium hydroxide, and it is heated at 150 degrees C. 150 degrees C, it forms sodium meta-aluminate. Sodium meta-aluminate. Sodium meta-aluminate is formed. So when it is heated at 150 degrees C, it forms sodium meta-aluminate, and this sodium meta-aluminate I am diluting with water, or I am adding water. Then a precipitate is formed. That precipitate is nothing but aluminium hydroxide is formed. So that precipitate is formed. That precipitate is nothing but aluminium hydroxide is formed. This aluminium hydroxide, when it is and this aluminium hydroxide precipitate is filtered. This aluminium hydroxide precipitate is filtered, dried, washed, dried, filtered and then washed and then dried, and then it is ignited at 1000 degrees C, that is heated at 1000 degrees C. It forms pure alumina. It forms pure alumina. It is heated at 1000 degrees C. It forms what? Pure alumina is formed. So here when you look at this this precipitate will be ignited at 1000 degrees C and it is heated to form alumina. Pure alumina is formed. That is the first step. Pure alumina that is formed. That is what the first step or the first process in the conversion of the bauxite into alumina using this Bayes process. So this is the first step. Then second step, the conversion of alumina into aluminium using Hall's process. Second step, conversion of alumina into aluminium using Hall's process. Or it is the electrolytic reduction of fused alumina. What is the formula for alumina? Al2O3. So this is the electrolytic reduction of fused alumina in which it will be converted into aluminium, that is Al. So we know that for an electrolysis we need a cathode. And the cathode is nothing but the iron tank lined with graphite. So here the cathode is nothing but iron tank lined with Fe is nothing but iron tank lined with graphite. And anode is bunch of electrodes. Bunch of electrodes dipped in molten electrolyte. Anode is bunch of graphite electrodes, bunch of graphite rods dipped in molten electrolyte. So what is the electrolyte? We are going to see what is the electrolyte used. Here the electrolyte is what? Cryolite plus fluorospar. Plus alumina, pure alumina. So the molten electrolyte is a mixture of alumina, cryolite and fluorospar. What is the formula for alumina? Al2O3. So the Al2O3 that we have obtained from the Bayes process, we are taking that alumina. To that we are adding cryolite. Cryolite is nothing but what? Na3Al(F6). To that I am adding fluorospar. What is the use of this fluorospar? This fluorospar lowers the fusion temperature of the electrolyte. So cathode is the iron tank lined with graphite. Anode is a bunch of graphite rods. And the molten electrolyte, what is the molten electrolyte? The molten electrolyte is nothing but pure alumina plus fluorospar plus cryolite. So this cryolite Na3Al(F6) and fluorospar, it is used to lower the fusion temperature. And we know that in the electrolysis process what happens? Anodic oxidation, cathodic reduction. So anode oxidation takes place and cathode it is reduction. Anodic oxidation and cathodic reduction. So here you can see I have dipped the electrode in the electrolyte. So when a voltage of 900 to 950 degrees C, temperature is 900 to 950 degrees C and voltage is 5 to 6 volt. Is passed at a temperature of 900 to 950 degrees C. What happens? The aluminium gets deposited at the cathode. The aluminium present in the electrolyte gets deposited in the cathode and oxygen gas is liberated at the anode. And it combines with the graphite and gives carbon dioxide. So in the cathode aluminium is deposited. Cathode la aluminium deposit aayirkum and anode la irundhu oxygen gas veliyagum. அது கார்பனோட சேர்ந்து கார்பன் டை ஆக்சைடாக வெளியே போயிட்டுருக்கும். அண்ட் கேத்தோடில் என்ன இருக்கும்? கேத்தோடில் வந்து the aluminium will be deposited. So in the cathode the aluminium is deposited in the cathode and oxygen gas is liberated at the anode. That oxygen reacts with carbon to form carbon dioxide. Then what is the overall reaction? So here reaction, the alumina, pure alumina gets converted into aluminium plus oxygen. So here this aluminium is deposited at the cathode and oxygen gas is liberated at the anode. This is the overall reaction. Again I will say here conversion of bauxite into alumina by Bayes process, that is the first step. In that you have obtained alumina, and this pure alumina is again reduced to aluminium using this electrolytic reduction by Hall's process. So here the cathode will be what? Iron tank lined with graphite, and anode is bunch of graphite rods, and the electrolyte will be cryolite plus fluorosphere plus alumina, and the fluorosphere is used to lower the fusion temperature, and when I give voltage of 5 to 6 volt and temperature will be 900 to 950 degrees C, it gets converted into aluminium, or the aluminium is deposited at the cathode. Aluminium is deposited at the cathode and the oxygen gas is liberated at the anode. So here the overall reaction is what? 2Al2O3 gives 4Al plus 3O2. Before that we can also write the cathode reaction as well as anode reaction. In cathode reduction we have to write, and anode it is oxidation. So anodic oxidation and cathodic reduction. So this is what the extraction of our aluminium. Then what are the physical properties? Physical properties of aluminium. What are the physical properties of aluminium? So it is very important. This can be asked in sums. The hint, so this can be asked as a hint or given as a hint in the problems. So first one, it is a silvery white metal. Silvery white metal. Silvery white metal, and its melting point is 660 degrees C. So its melting point is 660 degrees C. It has low density of 2.7, and it is light. It has a low density of 2.7 and it is light. It is malleable and ductile. That is, it can be drawn into sheets and wires. What is malleability and ductility? The tendency of a metal to be drawn into sheets is malleability, and ductility, the tendency of a metal to be drawn into wires. So this aluminium is malleable and ductile. It is a good conductor of heat and electricity. Good conductor of heat and electricity. Good conductor of heat and electricity, and it can be polished to give a bright appearance. It can be polished. When you polish aluminium, it will look like silver. It can be polished to give bright appearance, to give luster, that is shiny appearance. So all the properties of metals will be applicable to this aluminium. So aluminium is a silvery white metal, melting point 660 degrees C. It has low density 2.7, it is light, and it is malleable and ductile. That is, it can be drawn into sheets and wires, and it is a good conductor of heat and electricity, and it can be polished to give a bright appearance or luster. So luster meaning shiny appearance. Now we will see the chemical properties of aluminium. So in chemical property we will see reaction with air. Chemical properties of aluminium. We will see reaction with air. See, this aluminium is not affected by dry air, but when it is heated at 800 degrees C, it forms oxides and nitrites. It forms oxides and nitrites. With nitrogen it forms aluminium nitride. So this Al2O3 is alumina or aluminium oxide, and this AlN is aluminium nitride. Then reaction with water. So aluminium reacts with water to form this alumina plus hydrogen gas is liberated. Alumina plus hydrogen gas, that is aluminium oxide plus hydrogen gas is liberated. Then with alkali. So can you give an example for alkali? Alkali is nothing but sodium hydroxide or potassium hydroxide. That is, here aluminium reacts with alkali solution to form sodium meta-aluminate. Sodium meta-aluminate. Sodium meta-aluminate. hydrogen gas is liberated. In all these process, hydrogen gas is liberated. NaAlO2 is nothing but this one here, sodium meta-aluminate. So here when aluminum reacts with alkali, it forms sodium meta-aluminate plus hydrogen gas is liberated. Then with acids, with dilute and concentrated HCl, it forms aluminum chloride. Aluminum chloride plus hydrogen gas is liberated. So with aluminum, either it is dilute or concentrated hydrochloric acid, it forms aluminum chloride plus hydrogen gas is liberated. Then with dilute sulfuric acid, what happens? With dilute sulfuric acid formula H2SO4. With dilute sulfuric acid, it forms aluminum sulfate, Al2SO4 thrice plus hydrogen gas is liberated. Al2SO4 thrice plus hydrogen gas is liberated. Then this aluminum reacts with concentrated sulfuric acid. It forms the same aluminum sulfate, Al2SO4 thrice plus H2O plus 3 moles of sulfur dioxide gas. SO2 gas is liberated. SO2 gas is liberated. Sulfur dioxide gas is liberated. So with dilute sulfuric acid, hydrogen gas is liberated. With concentrated sulfuric acid, sulfur dioxide is liberated. So you have to look at the difference. With dilute sulfuric acid, hydrogen gas is liberated, but the product are same. Here also aluminum sulfate, here also aluminum sulfate, but with dilute sulfuric acid, hydrogen gas is liberated. With concentrated sulfuric acid, SO2, sulfur dioxide gas is liberated. Then reduction. Then the last one, aluminum as a reducing agent. Aluminum as a reducing agent. Aluminium, fifth chemical property, aluminum as reducing agent. So this is used in aluminothermic process. Aluminothermic process. So this is used in aluminothermic process. So aluminum is used as a reducing agent, which is used in aluminothermic process. For what it is used? When iron oxide, what is the formula for iron oxide? Fe2O3 is treated with aluminum and it is heated, it forms 2 moles of iron plus Al2O3. So this process is known as aluminothermic process. This process is known as aluminothermic process. So when iron oxide and aluminum is ignited, this iron oxide gets reduced to iron. Reduction is nothing but removal of oxygen. So oxygen is removed, so 2 iron plus Al2O3 is obtained, and this process is known as aluminothermic process. Here aluminum acts as a reducing agent. Then some of the uses of aluminum, we know it is used in household utensils. It is used in household utensils, in making aeroplane and in making industrial parts. So aluminum, it is used in household utensils. So aluminum is used in household utensils, in electrical cable industry. Then in making aeroplane and industrial parts. Then this aluminum alloy, this is used to make aeroplane and industrial parts. So what are the alloys that can be made? Duralumin, magnesium, you will study later. This duralumin and magnesium are alloys of this aluminum. What is an alloy? It is a homogeneous mixture of 2 or more metal or metal and non-metal. ஒரு மெட்டல் இன்னொரு மெட்டலும் சேர்ந்தது, இல்லை ஒரு மெட்டலும் நான் மெட்டலும் சேர்ந்தது என்னது அலாய். அந்த அலாய் எதுக்கு யூஸ் பண்ணுறோம்? இட் இஸ் யூஸ் டு ப்ரிப்பேர் திஸ் ஏரோப்ளைன் அண்ட் இண்டஸ்ட்ரியல் பார்ட்ஸ் ஆர் இண்டஸ்ட்ரியல் மெஷின் பார்ட்ஸ். ஓகே, இண்டஸ்ட்ரியல் மெஷின் பார்ட்ஸ். Okay, and it is used in electrical and cable industry, household utensils. Okay, and for preparing some of the cheap jewelry also this aluminum is added. Okay, sometimes this aluminum is used in household utensils, electrical cable industry, airplane and industrial parts. Some of the alloys like duralumin and magnesium is used in this industrial machine parts. So these are some of the uses of this what aluminum. So in today's class we saw about the chief ore, that is bauxite, and some of the ores of aluminum, that is bauxite, cryolite, corundum. Then extraction of aluminum involves two steps, that is conversion of bauxite into alumina. Conversion of bauxite into alumina by Bayes process, and I will explain the Bayes process. And from that Bayes process, second step is electrolytic reduction of alumina, and this is that electrolytic reduction, and in that we will get aluminium. And next one, physical properties of this aluminium, and this will be asked in one word. Many one word will be asked from this. It is a silvery white metal, melting point 660 degrees C. It has low density 2.7. So these are all applicable to only this metal. So this can be asked in problem, and it is used to solve the problem, and or this is given as a hint in the problem. And then chemical properties of aluminium: reaction with air. It reacts with air to form aluminum oxide, then reacts with nitrogen to form aluminum nitride, and here it won't react with cold water, it reacts with steam. So red hot aluminium reacts with steam to form alumina plus hydrogen gas, and then with alkali, when aluminium reacts with alkali solution, it forms sodium metaaluminate, and then next with acid, with dilute HCl, it forms aluminium chloride. And in each and every reaction, every metal, when you treat a metal with a concentrated acid, it will liberate hydrogen. So here hydrogen is liberated, hydrogen gas. Then with dilute sulfuric acid, it liberates hydrogen gas, whereas with concentrated sulfuric acid, it liberates sulfur dioxide, but the same product is obtained. Here also aluminium sulfate, and here also aluminium sulfate. Then the last chemical property, aluminium is used as a reducing agent. It is used to reduce another oxide. So here iron oxide, when it is mixed with aluminium, it gives iron plus Al2O3. So here Fe2O3 is reduced to Fe, and this process is known as what? Aluminothermic process. This can be asked in short answer. Now we will see some of the uses of this aluminium. It is used in household utensil, electrical cable industry, aeroplane and industrial machine parts. Some of the alloys like duralumin, magnesium is used to prepare this industrial machine parts. So here I hope you are revising the day-to-day lessons. Now we have completed one lesson, that is the first lesson we have completed, and now we are learning this extraction of aluminium. You learn the everyday portion and the portion for the unit test. So we have framed a timetable accordingly. The questions will be sent to you. So the portion for 10th standard is the first lesson. First lesson fully will have, and in that you have to study everything except the problem. Problems are not included. So please learn thoroughly. And you are I am not giving more homework to you. I know you can able to do only somewhat. So I have given only some of the homeworks. So except the problem, you study the lesson thoroughly. So I will ask questions from that lesson. One word, short answer, detail, you study, and except the problem, only the book bag alone you study. I will ask only the questions from the book bag. So this is the portion for the next unit test. So thank you for listening to me. Thank you.